Okay, today I want to record how I solve a LeetCode task. I have selected a medium difficulty task, max area of the island. Okay, in essence, you have a matrix, two-dimensional array, and islands are made of cells marked as ones, and zeros are water. Let's carefully read the task. You are given an m times n binary matrix grid. An island is a group of ones representing land connected two directionally, horizontally or vertically. Important point is not diagonally. You may assume all four edges of the grid are surrounded by the water. So any cells above, below, and so on, left, right, are water. Okay, here is input example and output is 6. Maximum island is 6. Example zeros is no island. Output 0. Okay, here are constraints which are important to look at. So m and n are sizes of the grid. This is height, this is width, and they can be up to 50. So the whole field can be up to 2,500, 2,500. Original values of the grid is 0 or 1. Okay, here is our input data, and we need to return the integer, the area of the largest island, number of cells in the largest island. Okay, the first thing I want to do is to copy this poorly organized input data list inside list into normal array. Import numpy as np. G, our new grid, is going to be np zeros. First, I will save m равно length of the grid. N is going to be the length of the first row of the grid. And then we create a new array m plus 2 by n plus 2 of the type np point int. I will explain why int, not bit or something, or int 8, because we are going to mark islands with numbers, and taking into account that we have 2,500 cells possible, the number of islands might be no smaller, at least at least 16-bit integer is required to number all islands. Basically 16 integer can be put, but that's not the point of this task. Okay, why I placed m plus 2 and n plus 2? Because I simply want to add margins. Can actually run code to test if what we are written, if what we have written is okay. Okay, answer is wrong because we haven't yet returned anything. Okay, let's go through the original grid for I in a range m. Here we do this. So we created a new array filled with zeros, and p zeros creates a zero filled array. So g e plus 1, okay, comma, and then to the area of 1 to n of n plus 1, from 1 to 1 at 1, we assign grid there. Okay, so this probably could be assigned in the one step, but that's too complex. Let's have at least one loop. Okay, we can try to actually print our new array. Oh, it's printed. So okay, see this one, it got margins. This largest island is here, so I simply added margins and transform it into a more faster array. Okay, what's next? Next we shall mark the islands, and I will use so-called wave algorithm. Let's copy it right from here, copy it again, G and N. So if G E 1 G plus 1, so I is row, G is column, equals 1, then we got the island. And what we do with the island, let's create an island and assign it to, okay, because we already have 0 and 1 used, then we got an island. Okay, and if we found 1, we assign it an island. And we are not yet completed here. So what do we do next? Next we should scan other cells of the island. Okay, we got upper left corner, not necessarily upper left corner, but first row or first column of the island. We don't know if it could be. It could go up, down, backwards, left. It's hardly going to go up, but it can go down and then to the left and so on. Nothing prevents it from being of weird shape. Okay, we assigned a new number to the grid. Okay, let's create some kind of a stack, and let's put this pair of indexes into the stack. Stack equals array for tuples. Okay, we can go from that point that direction. Okay, while length of stack more than 0, something left to scan, we do this. C cell, and it's equals stack point pop. So we extracted one element. Now for I will say DI DJ, not DJ as who plays music, but DJ as delta of index J and delta of index I. And we go through these values: -1 0, +1 0, 0 -1, 0 +1. So we can go into 4 directions. And here we place this. If we can actually copy this whole thing. Not exactly. Okay. If it equals 1, then E plus 1 plus DI, G plus 1 plus DJ. And if that equals 1, we for DI and plus DJ, and we mark it as an island number n. Okay, we can actually run code. It's not yet completed, just checking syntax. Syntax okay, the result not yet okay. Okay, and we'll do one more step. Stack. Not sure if list can have push in it, but add append. It doesn't matter in which sequence we do. So, and we append this. So we have found additional, okay, 2 parentheses, append. Okay, we appended. Now, what do we have? We have stack of one element. We scan it in 4 directions: up, down, left, right. We can find one. We mark it as island, and we append it to the stack. Then we can have a stack growing up to 4 elements at a time. So in the final analysis, we will scan the whole island. You know, we can actually come back to the same cell we were before. We can come back to this cell, but it's already marked as an island, and here we check it as equals to 1. So we find any island cell which is not yet marked by a new number. Okay, and actually we have scanned islands at this point. Okay, this became sort of code is going to the right. I might simplify it a bit. I will put this: if not equals 1, continue. And this like this. So the code shifted a bit to the left. Can we do it in some other place? Yes, we can do it here. If not equal 1, we can do continue. So it's not that weird looking now. Okay, now we have done all this scanning, and here we have marked all the islands. So we have found one, and then we mark it as a new island. Oh, one thing we forgot. Here at this point, an island should be incremented. Okay, because otherwise we will mark everything as 2. Okay. Now we need to count the largest area of the island. How do we do it? Okay, let's create a dict for islands. And let's repeat this range. If equals 0, continue. We are not interested in water. And here we do this. Let's simply create an island. An island. Okay, forgot my English. Okay, island equals this. If and island equals 0. Okay, if this island in D, then the island plus 1, else the island equals 1. So if it's not yet, we assign 1. If it's already been in dict, we plus 1. Okay, let's actually put print here and see what we've got. Okay, this is original picture, and here we've got marks. Something went wrong. Islands are not properly scanned. So 0, 1, 0, plus 1 x. What did I do wrong? Did J? Did J? Stack append. Well, let's see. No, this is what I have extracted C. Okay, that's not what I should have extracted. I should have extracted some indexes. Indexes are here. And that's what I deal with. Okay, so we are not dealing with I and J, we are dealing with those indexes which are in stack. Index 10 was out of the bounds. So we went outside. G plus 1. This could not be outside of the bounds. This could increment a bit. AJ no, we should remove this once. We have we already amended them. Okay, these plus ones are not needed. Cool. Yes, and we have marked islands properly. 6, 7. Okay, now what we've got in the dict. No, it doesn't predict like this. Okay, so for an island in the point keys, max area equals 0. That's what we should return if no islands are found at all. Okay. If above max area, which is 0 in the beginning, then max area equals what we found in the dict. Return max area. Wrong answer. Expected 6. Yes, we should have 6 numbers in the dict. We can print the island. 6 is present. So, what I wrote, what the sheet I wrote, this is of course was meant. Wrong answer again. 5. One, 4, 4, 5, 6. What have I done wrong? Ah, this is what I have done wrong. It's late into the night. Yes, we got the right answer. Okay, let's remove this print. We can actually retain all these prints. Run code again. Okay, let's submit. Okay, we solved it. We're not the best, but we have solved it. All tests have been run and we're okay. Okay, we can comment these 2 prints, which can have consumed some time, and submit again. Actually, it was pretty fast. Now it's even faster. Well, we are not super fast, but we're faster. So we have found the area of the largest island in the grid.